In this video, I wanted to explain some of the card sort that we have. I'm not going to go through every single card, but I want to go through some of the rationale because I feel that, I don't know, I feel like looking at the notes on their own isn't quite enough to understand it. Yeah. Okay, so I'm going to go through a few cards. I'm going to start with this card here. So it says the sum of two rational numbers is irrational. Okay, so remember, rational numbers are friendly numbers like 7 and 3.5 or something like that. So when it's talking about the sum, it's saying that I'm adding those together. Well, like 7 and 3.5, that's going to turn into like 10.5. Now, for it to become irrational means that you would start to have weird decimals that don't repeat, that just kind of go on for forever. But there's no way to have two friendly numbers that are going to do that. So that's why this card is never true. All right. In general, when you have any two rational numbers, you will always produce another rational number. I'll add that as a note. So any rational and rational number will equal a rational number. All right? It's not always the same with irrational numbers. And it's not always the same when they're mixed. So let's try it. Let's look at this one. So the sum of two irrational numbers is irrational. Well, I mean, if you do like square root of 7 plus square root of 5. All right, we could even do that on a calculator. Where's my Desmos? Okay, so I'm just going to plug it in a calculator. Let's look at what the square root of 7 and the square root of 5 does, right? So here's the square root of 7. Make sure to click outside the square root. Plus the square root of 5. Right? That's irrational. 4.88181928. Like, there's no pattern. Okay? So that checks out. That's irrational. But what we want to do is we want to test. Is there something that I could add that would cause it to become 0? Okay? The kind of check for adding and subtracting, you're going to want to try to make it equal 0. For multiplying and dividing, you want to try to make it equal 1. That's the goal. Well, if I add negative square root of 7, isn't that the same thing as subtracting? So any number minus itself is 0. Ooh, 0 is rational. So that's why this one is only sometimes true. Because I was able to find a case in which it was irrational, right? It went on for forever. And then where it equaled 0, which is rational. And that's kind of the name of the game here. This difference situation will also be sometimes true. Because if I change this to a minus, right, it's still irrational. And if I take this out of the parentheses, and now it's a minus again, root 7 minus root 7 is also rational. So that's why this other one is sometimes true. Let's talk about products. Let's erase some of this stuff. So a product is multiplication, okay? So it says the product of two rational numbers is irrational. All right, well, rational numbers are like 5 and 3. So if I multiply those together, I get like 15. But really, I can't see any other way to multiply two friendly numbers, even if it's like 5 times 1/3. Ooh. That's 5/3, which is rational. There's no way to multiply two friendly numbers and have it just kind of yeet off with that irrationality. There's no like square root or anything on there. So that's why this is never true. Remember how we were saying rational and rational together are always rational? Okay, let's talk about a product. Okay, so we're looking at irrational numbers. So if I pop some square roots on here, square root of 5 and the square root of 3, let's check it out in Desmos. So the square root of 5 is that's why it's irrational, times the square root of 3. Do you see how it goes on for forever with all this weird, icky yuckiness? So that's irrational. So now I want to think, can I multiply something by the square root of 5 to get rid of the square root? Well, with square roots, if you multiply a square root by itself, the square roots cancel out because 5 times 5 is 25, and the square root of 25 is 5. And that is rational. So that's why this one's sometimes true. So I only went through some of them because I want to keep the video short. But that's kind of our rationale, is to see, like, can you find a case which will cause it to be rational or irrational?